Hello everyone. Today we are going to discuss polymorphism, function and operator overloading. Okay. We have just finished with the topic called constructors, destructors. The topic was formally finished here, but actually there is there are many more things to learn in that we will keep on discussing throughout the rest of the C++ training. The polymorphism means, poly dictionary meaning means many, morphism means form. So what we are going to see is how to have many forms of any function or any operator that we will use in C++. It means giving more than one meaning to the operator or to the functions. What operators? It could be arithmetic operator, plus minus, relational operator, less than, greater than, unary operators, insertion, extraction operators. It could be all kind of operators that are used in C++, and it could be any kind of user defined functions that you will write. So we have to learn how to apply polymorphism, means give more than one form to both function overloading, to both functions and to operators. Okay. Now, we will start with function overloading. We will start with function overloading. Multiple functions with the same name but different parameters could be overloaded, like this. I'm going to start a new Jamboard for you, and in the new Jamboard I will explain you about polymorphism. New Jamboard. One 53.002. This is polymorphism. Yes, it says multiple functions with the same name but different parameters. Suppose you have a scenario here. Look at this. I have a function here called add. I have another function with the same name, add. But in this function I have two arguments which are integers, whereas in this we have two variables that are two arguments that are double. So the data type of the arguments are different. Okay. So when you make a call to this function, suppose you make a call to add function and you give 5 and 3 as argument, then this function would be invoked. And if you give 5.5 and 3.3 as argument, then this function would be invoked. Which version of add gets called depends on the arguments used in the call. So if you have these two functions being used in your call, we have a integer function and we have a double function with two integer arguments, and we have two, I'll explain you here, arguments which are double. Now when you make a function call, suppose you call the function like this, you call the function add and you pass 5 and 3 as arguments. Now 5 and 3 both appear to be integer arguments. So therefore this integer version of the function would be invoked as the arguments appear to be integer type. So function with integer arguments is called. Okay. Whereas if we call the same function like this, add 3.3 and 4.4. Okay. Here both the arguments are float. Isn't it? So the function with float arguments is called. Okay, that is this one. So there you see, you have two forms of the same function called add. This is example of polymorphism. This is example of function overloading. So you can say this is polymorphism. Or function overloading. Okay, right? Now, how does the C++ determine function calls determine that when the function call is made, then this function call will mature into which of the two functions? Which of the two functions will be invoked? What are the parameters which determine? Well, primarily there are arguments are the ones which are used to determine that the control will go to which function. But how about arguments? What among arguments are factors? The important factors are determining function mapping, what are the factors? Factors are, first, data type, of arguments. Second, number of arguments. Third is order of arguments. These are the three things that determine that when the function call is made, it will mature to where. Okay. Multiple functions with same name. It is possible to define functions with a different number of parameters because number of parameters matter. Note that the function's return type is not involved in making the decision to where the function call will be made. Return types are not determinantal. Okay? Don't use return type. Return types are not used to determine where to map. This is an important point. Okay? Fine. Important point. Now let us implement a small program first of all to consolidate on our concepts about what we are learning. So I will create my own program here. Function overloading. Watch this carefully. This one program will be more than sufficient for you to understand almost everything that I wanted to tell you. If I show you the programs which are already written, you will see it and you'll not be able to absorb the things that I want you to. So therefore, I'm implementing it myself. As usual, we start with modular structure programming. We will have headers.h, header file, and in this header.h header file we will put include IO stream. See, all of you who are taking training here, doubts will keep coming in your mind. Whenever you are able to understand, if I ask something, or if you are able to understand everything, and then you will respond to me in a single character. Y means yes, N means no. Okay. If you have any query, you will say question mark for query. Okay. If you have doubts, if you're not able to understand what I'm saying, then you'll put exclamation mark, not able to understand. Okay. So these abbreviated characters you use frequently in your chat. Because I'm going to remove my headphones, I keep my headphones in my ear for such a long time, then it irritates me. So depending on what you're putting here, I will put on the headphones and then respond to your queries. Okay, I have the header file ready, iostream.h. Then after that, I have to use declarations.h. In declarations.h, we have to declare space, namespace, using namespace std, and then we have to define our class. Suppose I take a simple class called addition. Okay, and in this class you have a private section and a public section. In private section you keep two data, integer no you keep in public section you will keep constructor function, and you will have a function called add numbers. Argument will be integer and another integer. It will return integer. Then you'll have another function add numbers, in which the argument will be float and float. So in the private section you'll have float a and b and s for sum. These are the three private members. So see, you have two numbers, functions. Then I'll have int get numbers function. Okay. Yes, Vedant? Yes, Vedant? Please speak up. Then we'll have display function. Remove these two. No, suppose here you have only fine, the class is given. Now let's go to the main function. Vedant, you can ask your query, I think. Okay. Let's write the main function. We have to include both the header files. Yeah. Now see out. Function name, begin, end line manipulator. You can write a query if your mic is not working, Vedant. If it is important, you can write. Otherwise, you write a query in the discussion forum if it could be taken later also. Now here, what we are going to do is we have to declare objects of the class addition, and object, say O, B, J. So when you declare the object, you have a constructor, 0 argument constructor. This would get invoked, isn't it? So let's implement the 0 argument constructor first. Here it is. No return types. Scope resolve to addition class. Constructor name addition. No arguments. Using initializer list, we will initialize your private members to value. Private members are A, B, and sum. A will be initialized to 0, comma, B will be initialized to 0, comma, sum will be initialized to 0. And then you'll say function name addition, begin. You also say that it's a zero argument constructor. Yeah, that's right. This should be 0.0. Sum is output, and I think output is not supposed to declare the private section in my point of view. See, the C++ programming is all about program design. There is no hard and fast rule as to what should be in private section and what should not. But yes, the general understanding is whatever data is important, it should be in the private section. Okay. So the zero argument constructor is written. Then after that I have to write another function called get numbers. Okay, these two numbers has to be sent in by the user. So let us write this function. The function is called get numbers, I believe. Get numbers. Get numbers dot cpp. Here we are. The return type is integer. The scope function scope will be resolved to class addition, scope resolution operator, get numbers. We have to enter two numbers. The two numbers will be, first give the prompt to the user. Enter two numbers, and the numbers are as given in the class A and B. A, another number B. Both will be entered here. Fine. Get numbers function is done. Then we have to implement display. .cpp. There is display. The return type is integer. The scope resolved to the class addition, scope resolution operator, followed by the function name. Okay. In this we have to display the first variable A and the second variable B and their result. So we will display it like this. The first number A, and then the addition character plus second number B, and then the equal to sign, and the next number, which is sum, printed. So display function is also done. Now we come to the real thing. Add numbers. Two integers. Now let's copy this to add numbers. Integer version .cpp. Enter. Now again the return type is integer. The function name is scope resolved to the class addition. The scope resolution operator resolves the scope of this function. The name of the function is add numbers. And it has two integer arguments, x and int y. And then it'll print the numbers, add numbers function, and in bracket you say integer args, okay? So that you know which one is executing. Both the functions will have same name. Here you have to add, take a local variable, the global variable, private variable sum is equal to A plus B. No. Let's modify this. Let's not keep A and B as arguments. I was thinking this right from the beginning. Only the sum. Now in main, what we'll do is we'll declare the object. After declaring the object, in main we'll call obj object dot function name get numbers function, and in this function we will pass two variables which are integers. As arguments. Enter two integer numbers, and you save it in local variable here. Instead of a private member variable, I am converting into local variable. Use cin in a local variable called a and a local variable called b, and then you pass this a and b as arguments. A and b has been passed as an argument, and both are integers, int a and b. So we have an integer and an integer, two integers passed as get numbers, and comes in here. Okay, because we have done some changes in the private section of the class, let us change the constructor also. We don't have a anymore, we don't have b anymore, we just have to assign sum. That's it. And when we go to get numbers, in get numbers also we don't have to get the numbers, so this function is not required, isn't it? Not required at all. Go to the class get numbers functions, which is because the get number task is done by the main itself. So let's remove it for the time being. So the get number function we remove. Slight change in the design. Remove. Yes. Now I hope everybody is comfortable with this. So get number functions will not be used. Instead it will be add numbers, which is the polymorphic function for us. Add numbers. The add numbers function with two integers value will be called, and it will return the result. The result we have to preserve somewhere. We'll do that. So let's go to add numbers. Integer version. Here we are. The two integers that are supplied as argument from main, a and b, are captured in int x and int y. Sum is equal to x plus y. We'll do x. Yes, Gaurav, that's right. X plus y, the formal arguments added, and then the sum will be returned. And the returned sum will come to main and will be captured here in some variable called result. No, straight away print it. See out. You will print result here. Return value. Result will be return value from obj. You don't know whether this will be integer or float, whatever it is. But yes, whatever it is, it will be printed by cout. So function call is made. And the result is printed. Right. We'll have a similar kind of function, another function, which will take, the file name is different, but inside the file when you open, here, the arguments will be float and float instead of integer, and obviously the result will also be float. Okay, so the return sum is done. So this is also implemented. So in the main, we'll call this function now. Enter two float numbers. Entered in two float variables, float say C and D, and stored float values stored in C and D, and you call this function using float C and float D. Okay, and this time you will see that the float version of this function will be called. Integer arg was the previous one, and this is float arg. Okay, done. This is also done. C and D. Okay, done. Oh, display we have not yet written, so let's comment it for now. We are not interested in seeing the result, so display we'll use later. The return type has to change. This will be float. Headphone लगा ही लिया मैंने. You can speak, all of you. Okay, so let's see if it works. We have to implement a make file for this. And make file is a shell script which will use the bin bash shell, and we'll create addition program which will take main.o, then what are the other files? Addition 0.o, then addition number.o, int.o. Yes, who's that? This is also O, add number integer taken. Another file is add number float. Another file is done. Then the rule gcc-o will create the target. Then we have to create sub targets for all the files. Main.o g++, right? Main.o will be created from main.cpp headers.h declarations.h, and we will be using g++ compile only main.cpp. Do the same thing for add numbers int. No, addition 0. Notice the class name addition I given capital. This is my habit, it's not a rule. I always know that if some name is given by capital letter, starts with capital letter, it's a class name. Add numbers integer. Add numbers float. That's all. 1, 2, 3, 4, done. Let's build it. The building process have started and declarations.h in main.cpp is a spelling mistake. Make again. Declaration.h in addition 0, again spelling mistake. This will be everywhere. Make addition 0. Make, okay, addition 0, error, returning a value from a constructor. Oh, that's not allowed. Constructors never have a return value. So building and success. Build is successful and we have created addition. I run. Enter two integer numbers, 55, 44. So what happened? Result add numbers begin. Integer args function was begin, add numbers end. Did you see that? Add numbers begin with integer arg function and it is over. And this is the result. It's not printing properly. I did not like it. Hold on. So here in line number 13, after the printing is over, I should put end line manipulator. Anything, any other modification? Main result. Okay, fair enough. Build again. Run. Two integers, 66 and 33. So here it is. The main is going to print the result. In the process of printing result, it called add numbers integer arguments version. Okay. Again, I entered two value 44.44 and 66.66. Now see, the float arguments function was called. The name of the function is same, add numbers, add numbers. But depending on data type of arguments, different functions were invoked. This is a simple, straight, perfect example of polymorphism. I do some modification in this. Let us see if it works. Just watch carefully. Enter an integer and a float. Okay, and I'll store the result in an integer a and float c, and I'll pass a and c as argument. ये तो mixture हो गया. This is a mixture. Now I had a polymorphic function with two integer arguments. I have a polymorphic function with two float arguments. But look at this. I am passing an integer and a float mix. Let's see what happens. Make. Oh, there you see. Compiler has a problem. You don't have a polymorphic function defined which takes the integer and float both. If you notice the statement that I gave you here, order of arguments, data type of arguments, both matter. Here data type of both the arguments, either integer or float did not match. So the solution to this is that you write another polymorphic function which will take an integer and a float as argument. Yes, Deepak, you can ask me a question. Yes, certainly we can do that. Look at this. And I think you know now what needs to be done. You will call it like this. Enter a float and an integer values. So you'll take the float first. C and an integer A. Line number 17. Yeah, we need to put end line here, manipulator. Here also. Here also. Good. Okay. Now we'll have all the functions. We have to have all the functions with the proper, order, type, and count, number of arguments matching. This will be CA. First float, then integer. Correct. Very nice. So let's implement these two also. Okay. So now we'll have first integer, then float.cpp. Yeah. Now it will create problem. Right now the compiler optimization is enabled, so it is doing some adjusting and fixing for us. So here also we have to change it to float. Float. So because this was given as float, so therefore C++ understands that we have not programmed it properly. It automatically, implicitly, it is doing changes. So then another version is here it is given. Okay. Yeah. Float. No. Both the arguments are integers, so this will be integer. Here both the arguments are float, so it will be float. It's fine. Yes. So it is doing adjustment here. So what is happening is C++ optimization is enabled. So though we have to learn explicit typecasting, that we'll learn in the coming classes. Right now the compiler optimization is happening, and it is adjusting the value type according to the pre-specified declared variables, data types. Later on, when we start pointers, we'll do implicit and explicit typecasts. There we'll have to do it. Okay. So this is the add numbers int float. So first int and then float, and it'll return the result. Add numbers float and int dot cpp. Here it is. So again, the function name is same. Here we'll have float, and here we'll have integer, and the rest of the function is same. So you can make it, compile it. You can add, do the additions to the make file, and run it. It'll work. It'll run. And depending on the data type, the type of the arguments, and the order of the arguments, int or float or int, you will see appropriate functions are being called. So it is my request to you to, after the class, take 1 hour slot and write this function exactly the way I have written. Have all the different kind of polymorphic functions, and implement this. See, it's a new topic that we have started today. Okay, and I request everybody to do your programs on par with the classes happening. Don't procrastinate it to tomorrow or day after tomorrow, because if you do on par with what I am training, then you will learn very well, very good C++. But if you do it later on, then your learning and absorption will not be as good as it is expected to be. Okay, so that's all I have for you today, and I'll catch you people again tomorrow. If you have any queries, please put in the discussion forum, and the link for the discussion forum is given here. Okay, you can find in EmbLogic site discussion forum, log in there and put in all your queries, discussions, doubts, clarifications or observations here. Fine. So that's all for today. Thank you all. Thank you very much.